Hello everyone. So in this video, we'll be talking about TCP/IP protocol over network for real-time control applications. So we'll be understanding this through a research paper. Let us go to the abstract. So basically, in distributed control systems, efficient communication between the control devices and real-time operations is really essential. And also coming to the traditional file buses through a effective and are now being replaced by economical and versatile solutions like TCP/IP protocol, commonly used in IT fields. So, talking about the proposed solution, so this paper proposes a modified version of TCP and IP for IEEE networks and which supports both asynchronous and isochronous data transmission. So the goal is to meet real-time communication requirements even when the mixed with non-real-time data. So talking about the key findings, experiment results confirm that the real-time data deadlines are met even when the network is handling normal data simultaneously. So this approach is adaptable for real-time control in applications like home networking, intelligent robots, and general distributed systems. So let us talk about the introduction part. So what is the role of networks in this control system basically? So in distributed control systems, the control computer network enables real-time operations, and traditionally these were like expensive file buses. Now which are ensured to real-time data transmission but had limited like high cost, complexity, and a lack of global standards. So talking about the TCP/IP and Ethernet advantages, with these advancements in network technology, TCP/IP and Ethernet have emerged as a cost-effective alternatives to find the buses. So, talking about the benefits, it is really inexpensive and it is neutral and it is compatible with off-the-shelf applications. However, like they are not naturally suited for real-time control due to issues like packet collisions or inefficient flow controls. So IEEE 1394 is basically a high-speed bus initially developed for multimedia applications, but also well suited for a real-time control systems. So it actually supports asynchronous transmission, making it a viable alternative to find both buses and TCP/IP over the Ethernet. Talking about the this paper, it proposes a modified TCP/IP protocol for IEEE 1394 to support the real-time data transmission. It actually ensures that the compatibility with the standard TCP/IP while meeting a real-time control requirements. So this actually the proposed solution handles real-time data, including both fixed period and deadline-based transmissions, along with the non-real-time data. So let us talk about the modified version of TCP for real-time data. So basically, let me give you an overview about the TCP protocol. So this is a connection oriented and ensures reliable communication using sliding window for the flow control. So however, it is the best effort nature, which can one lead to the unpredictable delays and impacting real-time performances, especially with the large data transmissions. So let me introduce what is TCP 13 1394. So this paper introduces TCP 1394, a modified version of TCP, what uses unused fields to support what real-time deadlines. We have also new flags here like TSP, which is known as time critical data, and ITM, which is a deadline success indicator, which are added in order to prioritize the real-time data. So talking about the bandwidth allocation and real-time handling. So TCP 1394 incorporates bandwidth with allocation states for asynchronous data transmission, ensuring that the reliable real-time communications happens. So this modification also improves two things. The one is flow control, and the other one is real-time deadlines. So now that we know the concept of modified TCP for real-time data, let us see the structures here. So the first one is the real-time data. It is basically a image where you can see the process. Coming to the B, it is a periodic data where the asynchronous log happens, and then there's a channel information. So it actually travels from the sender to the receiver. So let us see the structure where we have a socket interface, and there are different types of layers, which are physical data link, network layer, and transport layer. So coming to the physical layer, we have Texas Instrument, which is IEEE 1394 chipset. And coming to the data link layer, we have two Linux devices. And coming to the network layer, we have modified IP, and we have Ethernet. And coming to the transport layer, we have modified TCP and UDP, and which is basically a connection and connectionless, wired or wireless based. Uh, Next comes the socket interface. So let us know the experiment results. So when tested for real-time data using isochronous mode, IEEE 1394 bus demonstrated that more consistent performance even with the mixed asynchronous traffic. So latency test are on a normal TCP/IP with Ethernet revealed that the inconsistent transmission times for periodic real-time data failing to meet the deadlines. So, however, this TCP/IP 1394 over IEEE 1394, the latency remained within the short, predictable ranges, ensuring that the reliable real-time performance with the low deviations. Thank you.